Hello learners, I hope you must be preparing for your exams and the preparation must be going on in full swing. I'm your mathematics guru Shivani ma'am, and today I'm there to help you with another topic of Mathematics 2 book from HSC, that is Linear Programming Problem, also known as LPP over here. This particular chapter, when we talk about, actually is having a weightage of somewhere around 6 marks, जिसमें से एक 4 mark का question होता है usually, which is comprising of formulation of linear programming problem as well as solving it. Along with that, we also have sometimes 2 markers that is having just the formulation or just the solving part, not the total complete thing. So here in this particular part, first let's understand what exactly is linear programming problem. Now this linear programming problem is a tool which is used by industries, big industries, small industries, government sector industries to see to it that they can maximize their profitability, maximize their efficiency and reduce their losses, cost, wastages, etc. Now for this particular thing, they formulate a linear programming method. They formulate one equation, and on the basis of that they can decide that what should be the optimum production for them or what should be the optimum time allocation for them. The variables which are used over here are actually the raw materials, the time for a particular machine, manpower, the costing to the manpower, and so on. A lot of things can be utilized, can be kept inside this particular sector when we are calculating the linear programming problem. Now, as the name suggests, linear हमने इसके पहले किया हुआ है इक्वेशन के फॉर्म में, तो यहाँ भी हम इक्वेशन के ही फॉर्म में जाएंगे. Linear equation is always of the form ax plus by plus c is equal to 0 or ax plus by is equal to c. This is the format of a linear equation where there will be two variables y and x. Y is considered to be the dependent variable, x is considered to be the independent one. Using these variables, we can form a straight line because this is actually the equation of a straight line. The straight line can be like this, the straight line can be like this. Okay, so we can get the straight line over there. Now, once we get the straight line, we have to find out the feasible region of that straight line. Now, any straight line will divide the whole thing into two equal halves. If you notice that, we can get the things in two equal halves. Let's see, we're having this straight line. So there is one half which is below, there's one half which is above. Out of these two halves, one of that is our feasible region, which is required by us. So that we'll see, judge and formulate, okay, which one is the feasible region. Then definitely यहाँ पे more than one lines मिलेंगी आपको where you can have a common feasible region to get the final answer. That we'll see step by step. अभी हम करने वाले हैं एक एक करके, so that it will be much more clear to you that how we are going ahead with this particular topic. Now when we go with the first part of LPP, the first part actually deals with formulation of LPP. This question can come for 2 marks for the basic formulation, sometimes 3 also if they have more variables. Now for the formulation of LPP, first thing is your decision variables. Now these decision variables are the variables involved. It can be the product, it can be the nutrient, anything depending upon the question. We will assign them the values like x, y, z. Then objective function. Now this is the main function for that because what we are doing is basically for this getting this objective. Now this objective can be to maximize profit or to minimize cost. So the objective has to be very clear, which we usually denote with capital Z for maximizing profit and sometimes capital C to minimize cost. So once we get the objective function over there, the third thing comes our constraint. Because why are we doing all these things? Because definitely there are certain constraints, maybe the time constraint, maybe the raw material constraint. So those constraints need to be again decided on the basis of the thing that is, that what should be your values there. Now, these are the conditions under which the objective function has to work. Usually in a question, 2 linear constraint will be there. Sometimes you can get 3 to 4 also. So that will help you in getting the final feasible region. The last is another kind of constraint, which is non-negativity constraint. Now, whenever we are talking about the real life problems, like whether it's raw material or the time, most of the time, these things won't go into the negative bracket. That we can't have the negative time, we can't have the negative manpower. So in that case, in most of the questions, we'll get directly non-negativity constraint that x and y should definitely be greater than or equal to 0. So after having these 4 things, we can easily formulate one mathematical linear programming problem. So let's see one question over here and see how to formulate the problem and how to write it. So I'm taking the first question of the exercise 6.1, where the question is that a manufacturing firm produces 2 types of gadgets, A and B, which are first processed in the foundry and then sent to machine shop for furnishing. Now the number of man hours of labor required in each shop is basically given as maximum 60 for the foundry and maximum 35 for the machine shop. And we have to find the profit on the sale as A as 30, B is 20. We have to formulate the LPP to get the maximum profit. Now, what happens most of the times, question is asked by the students that how do we know what should we take as the variable? Because there is a big chapter, foundry, machine shop, hours, time. So the variable you always judge from here. That profit on the sale is rupees 30 and B is rupees 20. So your A and B, which are actually giving you profit, will be your variables. So your first step will be there that let X units of variable A are produced, or gadget A is given, so we'll use the word gadget, of gadget A is produced and Y units of gadget B is produced. You can't use the ditto marks in the examination. Please write the full statement. Okay, once you get this, we have to maximize profit. This is our objective function. Maximize profit Z is equal to. Now, by selling 1 unit of A, we are getting rupees 30. And 1 unit of B, we are getting rupees 20. So this is 30x plus 20y. Say if we are selling 5 units of X, so 5 into 30 will be the profit from A. If you are selling 10 units of B, so 10 into 20 will be the profit from B. So total profit we are getting as the sum total of this. As soon as you get this, now we go to the next constraint, which we decide with the thing known as subject to. This is the way we write. Subject to. So your first constraint we are going to see from the table over here. For your comfort, what we can do is, or what you can do is make another table for you for your understanding. So here, what I am going to do is A and B yahi pe hai. Maximum time I am putting over here. So A will be your X units, this is your Y units, foundry time and machine shop time. This is your machine shop. So foundry time for A is 10 hours, for B is 6 hours. This is 5 hours, this is 4 hours. Maximum time is 60 and maximum 35. Okay. So for foundry, the maximum time, we can write the time over here, that's fine. It will be easier for you to go with the things. That's 60 and 35. Now once you have this, आप इस टेबल को यूज करके इक्वेशंस फॉर्म करोगे. पहला इक्वेशन जो आपका आ रहा है, that is, since X requires 10 hours in foundry, so we'll be writing the time taken by X in foundry is 10x. Y requires 6 hours in foundry, so it is 6y. And the maximum time available in foundry is how much? 60. So the time can be used as less than or equal to 60. We can't go beyond 60, but it can be less than. So this is your first constraint which we are getting. Second constraint is with machine shop. Now in machine shop, X uses 5 hours, Y uses 4 hours, and the total time available is 35. So this is your second constraint. Along with that, we also get some more constraint, that is definitely, as I discussed, non-negativity constraint. So that will directly write X is greater than or equal to 0 and Y is greater than or equal to 0. So this is your final problem which you are getting. The formulation of the LPP is that maximize profit Z as 30x plus 25, 20y subject to these two conditions along with non-negativity constraint. And your question is done here if they are only asking for formulation of the LPP. Now, one more question let's take for the minimization thing. अभी तो हमने मैक्सिमाइजेशन का एक क्वेश्चन देख लिया है, तो लेट्स सी द मिनिमाइजेशन पार्ट. In this, in a cattle breeding farm, it is prescribed that the food ration for one animal must contain 14, 22 and 1 unit of nutrients, and two different kinds of fodders are available. Cost of fodder 1 is rupees 3 per unit, cost of fodder 2 is rupees 2 per unit. Now formulate the LPP to minimize the cost. Now again the hint for X and Y will come from this part, that the cost of fodder 1 and cost of fodder 2. So let X units of fodder 1 are used or are prescribed by them, and Y units of fodder 2 are used. Again, to go with this, easier to make the table here. Only thing what I'm going to add in the table is this. This is fodder 1, this is fodder 2, which we are going to go as X and Y. यहाँ पे आपका nutrients है, जो nutrients A, B and C. So this is 2, 1, first part. Second is your 2, 3 and then 1, 1. Now the minimum amount of nutrition required for them is 14, 22 and 1 for respective A and B. So this column will give you minimum value of nutrition. So minimum value here is 14, 22 and then 1. Now we'll start the problem. This is your basic homework which is there. Now we'll do the problem over here. First, we have to minimize the cost. Say formulate the LPP to minimize the cost. So हमारा जो objective function हो रहा है, that is minimize cost. Now the function I'm using as C for cost, is equal to 3x plus 2y. Because for buying 1 unit of fodder 1 is 3 rupees, so x unit will be 3 and then y unit will be 2y. Subject to, this is the way we write, subject to, now the constraints. First constraint is nutrient A require 2 unit of 1 and 1 unit of B, or second one, and minimum requirement is 14. So this will become 2x plus y greater than or equal to 14. Here, see to it. When it's the minimum requirement, your value will be greater than or equal. When it was the maximum value or maximum time, then it used to be less than or equal. Second condition same, बहुत easy होता है लिखना इस तरीके से, 2x 3y 22. This is what we have. So 2x plus 3y greater than or equal to 22. Last one again you can see 1x, 1y and 1. So x plus y is greater than or equal to 1, and definitely the non-negativity constraint which will be used, that x greater than or equal to 0, y greater than or equal to 0. And this is your final answer for this particular kind of problem. So formulation is one thing which you will come across, which can be for 2 marks to 3 marks, which I said in the starting itself. And then the next part comes, which is dealing with finding the feasible region using the graph. slightly time taking. In case if it's not coming for proper appropriate marks, like just 2 marks के लिए graph आ रहा है, try to avoid, because you have to do a lot of thing over here. But if it's coming a full question for 4 marks, go ahead with this. Even 3 pick, you can definitely try. Now first we have to find out here is the feasible region. Now feasible region is the set of all points where all the conditions or the constraints which we discussed are actually getting satisfied. Out of that particular thing, we have to find out one value where we are getting the maximum or the minimum values. So how to go with this? First, we'll get the solution set of variables which satisfies all the constraint. Then we find out the feasible solution area, and then we find out the optimum feasible solution from the feasible region. So let's start one question again, because here you can see that we are going to make graphs like this. On the graph, there will be the lines which are actually dependent upon the conditions given to you. And then we find out the feasible region. Now this is considered to be the feasible region over here. You can see that. Now out of this feasible region, we have to get the perfect answer, that which is the maximizing area or the minimizing point. So we find out the points, these are the end points which we take into consideration, and calculate the value of the objective function from those 4 or 5 points which we'll get from here. And then the maximum or the minimum or the required one will give you the final answer. So for this also, let me show you one question so that you can get an answer कि exactly कैसे ये question होगा हमारा वहाँ पे. So let's go with the first question itself. Easy one है, so that you can understand first. Then I'll give you one tough one also. Solve the following LPP by graphical method. Maximize z is equal to 11x plus 8y. Now we are subject to x less than or equal to 4, y less than or equal to 6, then x plus y is less than or equal to 6, and definitely the non-negativity constant x greater than or equal to 0, y greater than or equal to 0. ये आपका question है, which I have written on the board so that it's clearly visible to you people. Now when we make this graph, make sure आप negative parts को बहुत ज़्यादा दूर तक नहीं ले जाओगे, because हमारा major graph area will always be in the positive area. Okay. Now once you are having this, mark them. This is your origin. Then ये आपके x axis पे values जा रहे हैं 1, 2, 3. 4, 5, 6. It can go according to the question. मुझे वहां पे दिख रहा है कि 6 तक की वैल्यू से मेरा काम हो जाएगा, तो आई एम गोइंग विद दैट. Then here also 1, 2, 3, 4, 5, 6. Otherwise scale आप accordingly change करोगे. If the values are big like 24, you can see 30. So then change the scale आप 10, 20 के साथ भी जा सकते हो. Once you have this, we have to find out the first line which is given as x is less than or equal to 4. Now we know when we have to draw a line, and अगर आपको इसमें थोड़ी सी help चाहिए, I'm giving you the hint also how to make the line. X is equal to 4 के लिए go to the point on x-axis where the value of x is 4 and make a line parallel to y-axis. This line becomes x is equal to 4, and when we are writing on the graph, we are not writing less than equal to or greater than equal to, we are writing equal to 4 because the line denotes that. Now once you have this, now you have to decide what is your feasible area, because we are dealing with less than or equal to 4. So direct lines are easy to judge. Any value which is less than 4 will be towards the left hand side. Any value which is higher will be towards the right hand side. You can just judge x की value 3 है, which is less than 4. So this is your feasible area. Just mark 2 arrows below the first quadrant so that it won't hamper your graph. Otherwise graph में बहुत lines दिखेंगी, आपको difficulty होगी to go ahead with the question. After the first line, now we are going with the second line, which is dealing y is less than or equal to 6. Again, if y is equal to a or y is equal to b is there as the equation, आप y एक्सिस पे उस पॉइंट पे जाओगे एंड मेक अ लाइन पैरेलल टू x एक्सिस. This line becomes y is equal to 6. Again, we have to go with less than, so the value below. See, on x axis, left hand side is less, right hand side is more. On y axis, downwards is less and upwards is more. So this you're getting as y is equal to 6, and your feasible region is this, the complete lower part. But we are not going to draw this right now because we still have one more constraint equation. That equation is x plus y is less than or equal to 6. Now for this you have to take 2 points. You can make a table sort of thing also to make the 2 points. X, y. When x is 0, see what is the value of 5. So x is 0, y will be 6, and when y is 0, x will be 6. Just put them in this equation. 0 को डाल के आप दूसरी वैल्यू ले लो. It becomes the easiest way to calculate the points on the line. तो आपका पहला पॉइंट हो रहा है 0,6 which is here, and दूसरा पॉइंट हो रहा है 6,0 which is here. Join these 2 points to get the equation line. Straight line आपकी आएगी, okay, with these 2 points. Now when you have these 2 points over there, I'm just rubbing so that I can get a straight line here. अब इसका जो रिक्वायर्ड एरिया है उसको जज करने के लिए एक ट्रिक बता रही हूं मैं आप लोगों को. टेक एनी पॉइंट इन दिस एरिया और इन दिस एरिया. अब अगर मैंने यहाँ पे ओरिजिन ले लिया 0 + 0 0, so put x and y as 0 0. What are you getting? 0 + 0 is less than 6. So this is your feasible area. But in case if you feel no, मुझे तो कुछ और देखना है, why to check the 0 0 1? Let's take another point. यहाँ पे एक point ले लेते हैं 4 6. 4 6, 4 plus 6 becomes more than 6. So this is not a feasible region. So using this we can say that the lower region is the feasible region. Another small trick up your sleeve. Usually less than में everything goes towards downwards. Okay? Now ये अब आपका जो area है that is your feasible region which we are going to shade. And हर एक corner point को अब एक name दे देंगे. So this is O, this is A, this point becomes B and this point becomes C. बाकी सारे points तो clearly visible हैं. B के लिए we know we can see the graph and get that it is 4 2. Okay, and then go ahead with the question. Now once we have this, आपका statement आएगा next that the feasible region of solution is O, A, B, C, and then वापस write O. Okay, sometimes it is asked that why do we need to write O? So that we can say that the figure is getting closed here. This, and then going back here. Okay, this is the feasible region. And out of these feasible region, ये जो आपके 4 points हैं, उनमें से कौन सा point आपका feasible solution है, for that we'll make a table. जैसे अभी यहाँ पे आप देख रहे थे एक ऐसे table बन रहा था, ऐसे ही we are going to go with a table. Now let's make for this particular question when we are going ahead with this. For this table, I'm not erasing the graph so that you people can see the graph and analyze. आप ले रहे हो यहाँ पे vertex. Once you have the vertex, then the points over there, and then the value of objective. Value of objective. Objective आपका क्या है? यहाँ पे maximize profit का objective है. When you see the question, this is your first question, maximize z 11x plus 8y. तो यहाँ पे आप लिख लोगे z is equal to 11x plus 8y. Now let's make those values. पहला point है हमारा O which is 0,0. So your objective is also 0 plus 0 which is 0. Second is A which is 0,6. Always remember in the coordinate graph, we always write the x coordinate first and then the y coordinate. ये basics हैं आपके coordinate graph के. So now z will become 11 into 0 plus 8 into 6. So this value is coming as 48. Then the next value is b, which is 4, 2. So z is 11 into 4 plus 8 into 2. This is coming as 44 plus 16, which is 60, and c, which is 6, 0. So z is 11 into 6 plus 8 into 0, which is coming as 66. Now once you have this, आप इसको देखकर ही जज कर सकते हो कि which is the point which is giving you maximum profit. That's point C, where you are getting the overall profit as rupees 66. So आपका final answer will be there that the maximum profit, or to maximize profit, the solution will be at C, where x is equal to 6 and y is equal to 0, and the maximum profit is rupees 66. Profit rupees 66. I hope it is clear to you people how to go ahead with this type of question. एक छोटा सा क्वेश्चन मैं और ले रही हूं जिसमें कि हम लोग मिनिमाइज करेंगे चीजों को, so that you get a better idea कि exactly minimization में कैसे होता है. Let's take question number 5 over here. Let's take 6. Maximize का question है 5, 6. Minimize z is equal to 7x plus y subject to 5x plus y greater than or equal to y, x plus y greater than or equal to 3, and x greater than or equal to 0, y greater than or equal to 0. Now for 5x plus y, अगर आप इनके points पहले लेना चाह रहे हो, so this is x, this is y. When x is 0, y is coming as 5. When y is 0, x is coming as 1, because 5x divided by this. Now using these points, x plus y is greater than 3, ये आपका second point है. इसके लिए भी हम अगर एक table बना ले रहे हैं, x and y, when x is 0, y is 3, y is 0, x is 3. This particular part actually is being taught to you in grade 11th, जिसमें आपने ये लाइंस ड्रॉ करके feasible area को सॉल्व किया था. Not exactly in this particular manner with formulation, but you've done the basics over there. But still I'm teaching you from the base, I'm helping you with the thing, so that even if you have not done it in 11th, at least you can do it in 12th grade. Now here, आपको दिख रहा है मुझे y पे 5 तक जाना है maximum, 1, 2, 3, 4, 5. Please use scale over here so that you have the exact difference. Now first line 0, 5 and 1, 0. तो ये 0, 5 है, ये 1, 0 है. Join these 2 points with the scale and go ahead. यहाँ पे आप लिखना 5x plus y is equal to 5. Don't write greater than or less than on the line. You have to go with the desired area. Now since it is greater than this, let's take origin 0, 0. When we put 0, is 0 greater than 5? No. So what will we do? This is not our desired area. Desired area is somewhere here. Second line, 0, 3 and 3, 0. This is 3, 0. This is 0, 3. Join this. यहाँ पे भी आप इक्वेशन लिखोगे x plus y is equal to 3 is equal to desired area. Let's see, greater than or equal to 3. So we are having a point which is again 0, 0. If we are putting, this is less, so feasible region is upward. So overall feasible region जो आपको मिल रहा है, it is an open region passing through these points. Please shade them, and then you can specify that the feasible region is the open region having A, B, C as the vertices. सो ओपन शेडेड रीजन है, ये क्लोज नहीं हो रहा है तो हम O तक वापस नहीं आएंगे, इट विल बी जस्ट A, B and C and then we'll find out the table at this. Don't plot it this, नीचे बनाना आप उसे यार. So यहाँ पे आप points ले रहे हो, that is your vertex. यहाँ पे we have got 3 vertex A, B and C and then we'll calculate the minimum cost. Formula is coming as 7x plus y. C is this, yes, Z is 7x plus y. So at point A, the vertex is actually 0, 5. So this is 7 into 0 plus 5. Answer is coming as 5. At point B, the point B is your 1, 2. 7 into 1 plus 5 into 2, which is coming as 10 plus this 17. C is 3, 0. So here 7 into 3, 7 into 3 and 0, which is 21. Out of these 3, please be aware that what is your objective. If the objective is minimize, आपका answer minimum value होगा. If the objective was supposed to be like maximize, then the maximum value. So here your final answer will be that the linear programming problem is most feasible or optimum solution basically is at A 0, 5, where 0 unit of first thing x can be produced, or where x is 0 and y is 5 with the minimum cost of rupees 5. So this is how you can formulate and solve a particular question of linear programming problem. Now the third part of this, जो कि आपको यहाँ सीधे सीधे miscellaneous में मिलने वाला है, which will be your full 4-marker question as such. So this third part is dealing with a combined question, where first you have to formulate and then you have to solve. So you have learned both the parts pretty well, how to formulate and then how to solve it. So use the same thing and then get the particular answer. Like a carpenter makes chairs and tables. Profits are 140 per chair and rupees 210 per table. Both products are processed on 3 machines: assembling, finishing, polishing. And then you've been given the available time 36, 50, 60. I'm making the table here. This is question number 8. So the table will be like, it will be easier for you to understand. Product और machines over here यहाँ पे है. Product है आपके chairs. Already उन्होंने उसको x लेके रखा हुआ है. Table which is your y, easy for you. जितना काम वो कर देंगे हमारे लिए ये easy हो जाएगा. Then the maximum time जो आपका available time है. So available time आपको मिल रहा है hours में. First आपकी assembling machine है. Assembling machine पे it's going as 3 and available time 36. Second is your finishing machine and third is your polishing machine. So polishing machine पे भी you can see the things. Key values क्या आ रही हैं? This is 5, 2, maximum 50. This is 2, 6 and maximum 60. You have to maximize the profit over here, and the sales of chairs and profit, or the profit over there, will be 140 and 210. So first you will formulate. So write maximize profit Z is equal to 140x plus 210y. Subject to, now we are going with the constraints. पहला constraint आपका assembling machine पे है 3x plus 3y less than or equal to 36. Then 5x plus 2y less than or equal to 50. And then 2x plus 6y is less than or equal to 60. At the same time, non-negative constraint, x greater than or equal to 0, y greater than or equal to 0. Now, once you are at this particular answer, at this step, then you just have to now graph them and get the feasible region. हो सकता है जिस भी हिसाब से आपको एक region मिल रहा है, vertex form करो as I just explained in the previous one, and you will be getting your final answer. So this is how is your linear programming problem can be solved. Not a very difficult topic. अगर आप ये tabular form में बना रहे हो, आपका काम बहुत easy हो जाता है, because see, I've just done then 3x plus 3y less than or equal to 36, 5x plus 2y. So make like this. Don't try to do it orally or directly from the question. Make the table, take the help of the table and formulate. If the formulation is right, then half of the work is done. Then you just have to plot them on the graph, get the feasible region and come to the desired vertex. So this is one more topic of Maths 2 where you can actually score very good marks and increase your marks bank, you can say over there in the paper. So 6 mark question, attempt kar sakte ho aap. If it's a 4 marker, definitely attempt for the graph part. If the graph part only is coming for 2 marks, then it is time taking. So depending upon how you are writing and the speed of your answering, your speed of answering the paper will decide whether you're going to go ahead with this or not. But 4 marker may please attempt, and formulation is very quick. 2 marker formulation or 3 marker formulation, please attempt. So this is that particular chapter. Now I'll come with another chapter of book 1 in the next one, so that your balanced preparation is going on. Till then, all the best and see you all.